So hello everyone, welcome to the new video of NPTEL. So I'm going to start a new series of NPTEL. I will be giving here the and explaining here the solution for the design and analysis of algorithms. The programming question of this has came, that is week 2 question, programming question, and it's written just below the, it's just written here. This is the programming question of week 2, design analysis and algorithm, as I have told you, DAA. So let's try to understand the question. What is it trying to figure out? Let's try to figure out. The Siruseri singing championship is going to start, and Lavanya wants to figure out the outcome before the tournament even begins. Looking at past tournaments, she realizes that the judges care only about the pitches that the singers can sing in, and so she devises a method through which she can accurately predict the outcome of a match between any two singers. Okay, she represents various pitches as integers and has assigned a lower limit and upper limit. Okay, there is a lower limit, there is a upper limit. Let's give the lower limit as L, the upper limit as U. Okay, so okay, which corresponds to their vocal range. This is the range of the singer, the range in which the singer sings. Okay, range of the singer. Okay, for any singer, the lower limit will always be less than the upper limit, obviously. If a singer has lower limit L and upper limit U, that is L less than U, it means that that this particular singer can sing in all the pitches between L and U. So it can the singer can sing between L and U any pitch. Okay, so fine. That is, they can sing in the pitches L, L plus 1, L plus 2, unless it comes to U. Fine, that's pretty understandable. The lower bounds and upper bounds of all singers are distinct, all are different, all have different lower and upper bound, no one is same. When two singers SI and SJ, okay, when two singers with bounds LIUI and LJUJ compete against each other, SJ wins if they can sing in every pitch that SI wins if they can sing in every pitch that SJ can sing in, and some more pitches. Similarly, SJ wins, vice versa. If neither of these conditions are met, the match ends in a draw. In this problem, you can assume that there no match ends in a draw. Okay, fine. I will explain you the question once, then it will become more easy for you guys to understand. Suppose there is a singer 1 who has the pitch between 3 to 10. There is a singer 2, just imagine, this is an imagination case, who has 7 to 9. Okay, now the singer 2 can sing in the range of 7 to 9, that is 7, 8 and 9, while singer 1 can sing in the range of 3 to 10, that is 3, 4, 5, 6, 7, 8, 9 and 10 including. Let's assume. Now, can singer 2 sing what singer 1 can sing? No, it can't sing 3, 4, 5, 6. It can sing only 7, 8, 9, right? But singer 1 can even sing those pitches which singer 2 can sing. Try to understand, try to catch my words. Singer 1 can sing even those pitches which singer 2 can sing. So if I hire singer 1, I would have cost less and I have more variety, right? So that's why singer 1 here wins. Okay, singer 1 wins here. So that's what is my question trying to say. So yeah, and there is no draw here. Okay, n singers are competing in the tournament. Okay, there are not only two singers, there are n singers, that is more than two. Each singer competes in n minus 1 matches, one match against each of other singer. The winner of match scores 2 points. Okay, so 2 points for each match he wins, and the loser gets no points. But in case of draw, both the we don't have a draw case, so let's not read it. You are given the lower and upper bounds of all the n singers. You need to output the total scores of each of the n singers at the end of tournament. Okay, so yeah, solution hint is given, we don't need to read it. Let's just check toward the input format. Okay, now I will directly go to the sample input and output. So my sample input one is giving, there are five singers, one who the pitch of my first singer is between, my pitch of first singer is between 3 to 23. Second singer is in the range of 4 to 20. Third singer in 11, 16, 5, 19 and 125. So if I try to explain the question by this example, come, let's understand by this example particularly. I will write the input here. I will write in the format of my coding also, right? So that will be more easy to get. N equal to 5 and 323, 420, 1116, 519 and 125. Okay. If I go for the first singer 323, 323, can it win with this player? There are five players, one, two, three, four, five. Okay, one, two, three, four, and five. Can my player one win from player two? Yeah, obviously, because 4 to 20 is lying between 3 to 20. So player one gets 1 point. That is score is two. This is match won. This is the score, that is into two compulsory. Can it win with player 3? Yeah, again, because 11 16 again lies in the range of uh, 2 plus 1 into 2 again, that is 4. Okay, now can it win with player 4? 5 to 19 lies between 3 to 23. So yes, so 4 plus again 1 into 2, that is gonna give me 6. Okay, 1 to 25. Can it lie between 3 to 23? No. So my total score of player 1 is 6. Similarly, I have to find the score of 2. I have to compare it with 1, 3, 4, 5, 3, 2, 1, 2, 4, 5, 4, 2, 1, 2, 3, 5, 5, 2, 1, 2, 3, 4. And as soon as I get my output, I have to print that thing. So you can see the output also here, 64028. This is my output, right? Because my player 1 has scored 6, as I showed you. 2 is gonna score 4, 3 is gonna score nothing, because 11 16, there is no other singer who comes between 11 to 16, right? Right, that's why 0. So yeah, I hope you understood the question very well. Similarly, there is a second input also. So now let's try to come to the approach what we can use here. What we can use here, first I will try to list out the scores here. 323, let's take a 420, it was I guess, 11 16, 519 and 420, sorry, 125, it was 125. And now, can you see here pattern? Let's try to find some pattern out. Suppose if I am comparing 3 with all the players, we can see that 3 is smaller only from 4, 11, 5. It is not smaller than 1. So 3. Count is 3. Now let's check 4. 4 is smaller than 11 and 5. So for 4 the count is 4. Sorry, 2. Right, from only 11 and 5 it is smaller, so this count is 2. For my this third player, count is 0, because 11 is not smaller than any of the numbers, so count is 0. For my this number fourth player, 5 is smaller than, not 3, not 4, yes, for 11, not 1, so only 1. And this is smaller than everyone, so obviously 4. Now if I multiply all these numbers by 2, right, what am I getting here? 6. What am I getting here? 4. What am I getting here? 0. What am I getting here? 2. What am I getting here? 8. And do I need to print this thing out there? 64028? Yes, obviously, this was the printed thing here. 64028. You can see, you can check for yourself. Okay. You can check for yourself. So there is some logic between this. See, there can be more logic. I will show you one more logic. See, if I take the difference between 3 and 23, okay, what can be the difference? What is the difference? 20. Suppose I find difference 20, 16, 5, 14, and 24. Okay, 20 is greater than whom all? 16, 5, and 14. Okay, count became 3 into 2. 16 is greater than what? 5 and 14. Count became 2, 2 into 2. 5 is greater than only no one, so 0. 14 is greater than 1. 1 into 2, 2. 24 is greater than all. That is 4 into 2, 8. Simple. This can be one logic. One more logic can be with the second part of this player one. It is 23 is greater than how many numbers? Again into 2. That's three logics are there. You just need to go with one logic. So okay, fine. The biggest problem, or you can say the challenge, is gonna be in one part, that is what data structure should we use to store this thing out, this thing out, this scores, sorry, this players. What data structure should I use here? See, we have 2D array. Okay, I won't say that you can't do with 2D array, but it will be a bit complicated. So I would like to rather go with pair. What is a pair? I will just give a short recap. Okay, you can check out for one of my shorts. I will be preparing a shorts for pair. If I add this thing in this video, then it will be a long video. So pair is nothing but a pair, nothing but a pair. It will be having a pair of number. That is, suppose if it is not only integer, it can have anything, string pair, integer pair, anything. Suppose it is 3 6, so this 3 6 is a pair. Okay, this is a pair. But here I need a vector of an array of pair. This is an array of 5 pair. There are 5 pairs. One, two, three, four, 5. Okay, I need an array which is storing 5 pairs. So this is nothing but a array of data structure that can be used here is, one is 2D array. Obviously, I won't deny it. But the optimized thing will be a vector of pairs, or you can call it array of pair. Okay, both are same thing. Okay, vector of pair, array of pairs. Okay, fine. So yeah, this is the thing. Now let's try to go towards the logic part. How are we gonna save these numbers in the pair? Okay, because there are some certain formats by which we do that. First thing is, we need to know how we declare a vector of pair. I will write vector here. Okay, then I will write here pair, because I am going to declare a pair. You need to include here certain libraries, but instead of doing that, I will just include one library, that is bit slash std c++ .h. This will include all the that. So yeah, this will be the data structure vector of pair, and the pair is of int comma int, right? The data type is int comma int. I will close this part. Now I will just put the name of the pair, and the size is gonna be my n. Okay, fine. The pair is declared here. Declaration part of the pair is over. Before this, you need to declare the size of the inputs, total players. Now what we will do is, we need to take the input in this pair, right? So I will teach you the format how we take input inside a vector of pair. Just declare a for loop, start initialize the for loop. Okay, I int I equal to 0, I less than n, I plus plus n is the size of the vector, that is 5. Now how I take the input is, I take, see, before that I will tell you one small thing, that suppose if you want to access, there is a pair called 3 comma 23. Suppose I want to access 3. I can, this now name of this pair is p1, suppose. Okay, I want to access this 3. I can simply write p1 dot first, because it stores in this format actually. See, the compiler stores in this format. My 23 can be accessed as p1 dot second. So access, this will access 3, this will access 23. Okay, so for taking the input also, I can write the same, p1 dot cin of p1 dot first, cin in p1 dot second. Simple. Okay, same thing I'm gonna do here, cin, but here as it is vector of pair, right? So p1 of I, that is the first element of this empty first pair of this uh, you know vector. This I accessed this whole pair. Now I write dot first. By writing my dot first, it will access this. Now see, there is a pair here. Okay, so it will access this element, and it will put the input in through this location. Okay, similarly, if I write c in p of p1 of I, dot second, it will access this part. Just done. This will store the whole vector of pair. That's why I was saying going with 2D array would be a bit of complicated task, and this is an optimized data structure that can be used. So please try to use vector of pair instead of 2D array. Now I will go for now I will go for the logic part. How are we going to compare? Now we, after this step, after this, we have our input ready. Input ready. That was what? 323, then 519, whatever. I'm just not writing in a order. 11, 16, 420, 125. Okay, I have this ready now. Now I need to check whether my this is smaller than which all numbers. So obviously I need a count variable which will be the keeping the count, right? So now I will be declaring a loop which will be keeping the iteration on this pair. Suppose if I declare a loop on this pair, vector of pair, I will be keeping the track of the pair which is currently being accessed. So I equal to 0, I less than n, I plus plus. Now I need to check my first variable, this, with 5, 11, 4, 1, right? So okay, instead of, okay, fine. So my I is sitting here, right? I need to check this I with other numbers. So I can't shift my I to here, to here, to here, to here. I can't write I is less than I plus 1. I can't check this condition. You will have a doubt. Okay, so if I check this, then my 323 will be checking only with 519. It won't check with all these. Similarly, if I come to 59, then I will increment. It will come to 519. 590 will check to 1116. But no, I have to check with all. So I need a nested for loop here, right? I need a nested for loop here. So I will be declaring a j loop, initializing a j loop also here for int j equal to 0, j is less than n, j plus plus. Now one more doubt will come here. Can't I declare my j with I plus 1? Okay, I will clear this doubt. Suppose I'm sitting on 1116. Okay, now 11 has to compare itself with 4 and 1 only, or 3, 5, 11, 4, 1 all. I don't need to compare itself by itself, obviously. So leave this thing. Other numbers it has to compare. That means it has to start from 0 all the way. That's why we need to declare our j from 0. Okay, and after this, just a simple condition, that is, if, see the condition very carefully, p1 of I, right? P1 of I, if I write, I am accessing this pair currently, and I need to access the first element of this, right? So dot first, if this is less than the next like the other elements, that is j is going to access those elements. So dot first, right? I have to just increase the count. Simple. Count is becoming count plus plus, right? Simple. And after this count plus plus, I need to close the j loop also, because the work of j loop is over now, right? Now j loop has no work, because j is gonna run 5 times here, right? J is less than n, I have written, right? So j will currently from 1 it will start, and as I have written less than only, so it won't count this 3. It will start, it will see this 5. Is 3 less than 5? Yes, count became 1. Is 3 less than 11? Yes, count became 2. Is 3 less than 4? Yes, count became 3. Is 3 less than 1? No, count is still 3. After this, we have to come out of the j loop. We have to just, what do we have to do here now? I have to print this count. Nothing I have to do. I have to just print this count. But instead of printing this count, I would like to suggest you one more thing. I will tell you the reason why. I will tell you the reason why I want to suggest you this thing. What I am going to do, I will just make a new array here. I will make a new array of size again n, and I will be storing this count here. So I will store 3 here first. Okay. And for that thing to do, the most easiest way is to not declare an array and to declare a vector. This will be even more easy, because in vector you can directly use this function pushback. If you use this function pushback, it will directly push this count, to the first index, that is 0. It's like acting like a stack. So my 3 is getting stored here. Above this will come the next count. Above this will come the next count, like this, right? So I will be declaring a vector instead of an array. And let's do that work here itself. Vector, the declaration of vector is this. Okay, and I will not declare the size of this vector because after that I can't use pushback function. Just keep in your mind that this is the format of declaration of a vector, and above I have taught you the format of declaration of a pair also. This declaration format of a vector of pair, if you remove this vector, then it will be the format of declaration of pair. Okay, nothing tough here. Okay, fine. So I will be storing this count into this array. So 3 is stored by this. Now this line will store arr dot pushback of count. 3 is getting stored here. After this, what we have to do? Should I leave the count 3 only, or should I make it again to 0 so that it can be used for the next elements also? Obviously, we need to declare it to 0 again. So yeah, I declare it to 0. My I loop also closes now. Just this much work you have to do. Okay, now after 3 it will store you what it will store. Suppose just for example, I'm assuming it is coming to, then 4, then whatever it will store. Suppose only these numbers. After that, what I have to do? I have to just print this out by multiplying 2 into it. In all, I will multiply 2 and I will print out, because for every player, this is the number of players by which he has won. After this, we have to print the scores, that is multiply by 2. So yeah, I will multiply it by 2 and print it out. Okay, so yeah, let's come to that part now, printing part. So let's come to the printing part. I will just declare a for loop easily. See, printing an a vector or an array, you can use same format. Okay, you don't have to worry about it. Int I equal to 0, I less than n, I plus plus, C out arr of I. Simple, done. There is one more thing remaining here. I will tell you after showing the input, showing the code part. Okay, so yeah, done, over. Any doubt? If you have any doubt, just tell your doubts in the comment section. By the way, I will make videos on C++, stl, pair, vector, everything, so no need to worry about that. This is the main logic of the code. Basically, this is the main logic of the code. What you need to do, if you have understood the logic, that's enough. You can just use a 2D array and you can try it out. So yeah, this was the logic. Now let's go to the code part. So as I told you, I need to declare the count variable, which will be 0. I need to declare the vector, which will be storing, the scores, that is 3, not scores, the number of players with which they have won. Suppose 3, 2, 2, whatever they have to store. Okay, it can't be equal. So yeah, n is the number of players, those who are gonna play. Then I am declaring the vector of pair. You can see the same format here that I used above in the logic. I'll be sharing this PDF with you in the comment section, description section. Then I'm taking the input in the vector of pair. I told you how you have to take same your logic I have used here. Okay, then I'm gonna check my nested loop. I am gonna start from I equal to 0 to n, j equal to 0 to n, and I'm gonna check it here. You can check out for yourself how I have checked the same thing it is count plus plus. Then I'm taking the input in the v1 by using push back function, then count equal to 0, and at last I'm gonna just print out the second, sorry, the array, which is gonna store by multiplying 2. You can see by multiplying 2 I am printing. Okay, okay, fine. So yeah, this is my code here. And you can see for one thing, not, you will be thinking that I didn't include this thing in the logic part. That is, if I is less than v1 dot size minus 1. What is this? In my code, I wrote here itself this thing, right? But when I was submitting it, okay, the submission format is a bit different. They suppose if you are printing 6, 4, then 2, 0, and 8. Okay, if you put like this, C out 2 into ARR of I, and after that you are gonna put this space. Okay, if you will put this space will come after 6, then this space will come after 4, then after 2, then after 0, and after 8 also, which we don't need. in the output format given in the following question. Okay, that's why what I did is I need to print the space one less than the size of the array, right. Suppose my size is 5, I need to print the space only 4 times, not the last time. Okay, so for that reason I have kept here the condition that if my I is less than v1 dot size minus 1, that is 5 minus 1, then only I have to give a space, otherwise I don't have to give the space. That is last one, it won't take in the consideration. And after this I have given a cout handle because it was given in the output format, so that's why. And after this we have our question done. We don't have to do anything else in this question now. So this was the first programming question of the week 2 programming question of DAA, design analysis and algorithm. If you are not a part of this course, then also you should watch this lecture because I have taught a new thing, that is pair. I have taught you, see, with 2D array you can do, right, but learning a new thing that is pair, here is a good excitement, and that also in such a less time. So yeah, thanks for watching my video. Bye bye, keep coding. Jai Hind.